All right, as promised, we're back with the problem set. So let's get started here, okay? The light, right? It says solve 14 times 12 using 4 partial products and 2 partial products, okay? Remember to think in terms of units as you solve. Units, when we say terms of units, instead of saying 4, we would say 4 ones. Instead of saying 10, we would say 110. We can think that way, but we're not going to write it down that way, okay? It gets kind of confusing when we start juggling around with all these words, okay? So I just want you to understand units is when you say the place value with the number, okay? As you solve. Write an expression to find the area of each smaller rectangle in the area model. Now we can do that. An expression is just a number sentence, okay? Okay, so let's get started here. Here we have 12, or that 14 times 12, okay? So what I do here is, we talked about this yesterday a little bit, but I always start here in my ones place right here at the bottom number. So I'll say 4 times 2. 4 times 2 is 8. So this is my partial products there. So 4 times 2, that would be my 8 right here, okay? It's a small box. I'm not really going to be able to fit in my number sentence. I will in the bigger boxes, though. Now that I did 4 times 2, I want to come back to this 4, and I want to say, well, it's 4 times 10, right? That 1 is in the tens place, so I'll say, what is 4 times 110, right? I know 4 times 1 is 4, but it's in the tens place, so it's 40. So that's where it goes here, that's 40. And you can see here it's 4 ones times 110. It's basically 4 times 10, right? So this is what unit form looks like, and this is what standard form looks like. Okay. Now, that 4 times 110 was this guy, and that was 4 times 10 equals 40. Now, I'm ready to go here. I'm going to move over to the bottom row here. I'm finished with this 4. I'm going to move over to the tens place in this 14, which is 110, or just 10. What is 10 times 2? And this is just 2 ones, right? So 10 times 2 is 20. That will go right there. And over here, I'm going to write that in. 10 times 2 is 20. There's my area model for that. All right, it's making sense? Hope so. Now I'm going to start with this guy again. Now it's his turn to get multiplied by that guy. So it's really one. It's not 1 times 1, but it's 10 times 10. It's 110 times 110. 10 times 10 is 100. Just like that. And that's where that goes. See, it's 10 by 10 equals 100. There it is. Now if I add all those up, 8 plus 0 is 8. 4 plus 2 plus 0 is 6. 168. Okay? Now that was our partial products, that 4 partial products did. See them? 1, 2, 3, 4. And then partial, because they're just pieces to the whole, we add them all up, we get 168. We did this problem yesterday as one of our first problems. Okay, now over here is where we get to our standard algorithm, okay? Our standard algorithm will look like this. So instead of splitting this 10 into a 10 and just 12 into a 10 and a 2, we're just going to keep it at 12. We're going to say here, we're going to do this, and follow along with me. We only start here in this base number, 4. What is 4 times 2? That's 8. So follow with me. Then we're going to say that it's 8. And then I do 4 times 1. What is that? That's 4, right? And I write that 4 right there. So basically what I did here was, what is 4 times 12? And that is 48. So I'm just going to write it there. So instead of doing the partial products, I just did 4 times 12 and wrote my number down. So instead of doing it like this, I just combine those. See how my top 2 numbers is 48? So this would be our 4 times 12. Okay? Then I'm going to do 10 times 12, which would be 120, right? Let me show you how that works. So now that I've taken care of this 4, now I'm going to move over here. Okay? But before I go there, I need to put a number down here. What I need to do is, when I move to this 10, I need to put down a number here to hold the place. Okay? And what is that called? That is called Bob. All right? We can call that guy Bob or Bartholomew or whatever, but we can't forget about this guy. Once I move over to the tens place, I come down here, I must put a 0 in to show that I'm multiplying from the tens place here, okay? Because a 10 has 1 0. All right? Now watch what I do. 1 times 2 is 2. 1 times 1 is 1. So, see that 120? There it is. So, these two numbers, when I added together, that's what it was, 120. Now, I add them up. 8 plus 0 is 8. 4 plus 2 is 6. 1 plus nothing is 1. 168, 168. Careful now. It's kind of cool. It's interesting. It's fun. Okay? So this is the standard algorithm. This is how us teachers are really going to hammer into you how it's done, okay? We're super glad if you can do it this way with ease, but this way is how it's done quickly, all right? Let's move on to the next one. Let's give that a shot. All right, we're going to solve 32 times 43 using 4 partial products and 2 partial products. Match each partial product to its area on the models. Remember to think in terms of units as we solve. Okay. Remember what units are. These are terms of units. Okay, they're written down there. That's fine. Okay, let's get it done. I'm going to start with this guy right here, okay? If you remember which number we start with, we always go to the base number here and we start in the ones place, right? We always start there, okay? So now I go 2 times 3, and we start in the ones place. So 2 ones times 3 ones. That's just a regular old 6, right? There's my 2 times 3, that's 6. Then I have to do 2 times 4, but it's in partial products mode. It's 2 times 4D right here. Wouldn't that be 80? 2 40s is equal to 80, right? So I write that 80 down here. Cool. Now I'm done with that too. So I move over to this 3, which is in the tens place. So I'll say 30 times 3. There's my 30, there's my 3, okay? That would be 90. Because 3 times 3 is 9. Bring my 0, it's 90. Or if I just count by 30s 3 times, 30, 60, 90, I'll get that. And that guy goes right there. 3 tens by 3 ones. Finally, I got 3 tens times 4 tens. Or 30 times 40. That would be 12 with 2 zeros on the end. Because 3 times 4 is 12, right? But there's 2 tens, so I put those in there. So it comes out to be 1, 2, 0, 0. Let's add them up, see what we get. 6 plus 0 plus 0 plus 0 is 6. 8 plus 9 is 17. Put down the 7, carry the 1. 1 plus 2 is 3. And don't forget about that guy there, 1. This comes out to be 1,376. Good. All right, if you know anything about, we talked about memory yesterday in Mrs. Bushy's science class. My memory tells me that these 2 numbers up here is going to be my top number here, and these bottom 2 numbers are going to be here, okay? So let's check that out. When I multiply the standard algorithm, those 2 numbers are going to be in that area right there. That's 86, isn't it? That's right. And then these 2 numbers added up, it's going to be in this area over here. And remember, that's not 190, it's just 90. That 1 was the place I carried. So this would be 1,290. Let's see if we're right, okay? So we're going to do 2 times 43. See that? Start here, we go 2 times 43. But this is how it's done. We say 2 times 3, that's 6, right? And then 2 times 4 is 8. 86, 86. See how that works? Isn't that cool? Right? We've done 2-digit by 1-digit multiplication before. And there it is. Done. Now, we're going to move on to our tens place. And when I move on to the tens place, down below this number, I need to put in my special 0. What do we call that special 0? Steve? You want to call him like a certain name? Okay, we're going to put him in. Mrs. Bushy's always been, it's Bob. So just don't forget about Bob. All right, so we're going to put that 0 in. Now we can just multiply regular, okay, because it held our place. 3 times 3 is 9, right? And 3 times 4 is 12. There, look at that. There's 1,200 plus 90. Remember that 1 was a carried. No, let's just get rid of that. So it's right. I add them up. 6. 8 plus 9 is 17. 1 plus 2 is 3. Bring down to 1. 1,376. 1,376. Man, that's pretty good. All right, what do you think? Yeah, I love this. Okay, and I could put down 2 times 43 here if I wanted, and I could put down 30 times 43. Okay, that's what it comes out to be. Let's check out the back. Okay, well, not the back of this one. I always print out extras so I don't have bleed through. Okay, all right, here we go. So it says solve 57 times 15 using 2 partial products. Match each partial product to its rectangle in the area model. Okay, so the area model is just going to look like this. And we're just going to do that. Okay. What I'm trying to do is it's asking us to do this part right here. Whoop, if we get it right at the center of the screen, it's asking us to do this part right here. Okay, so that's what I'm going to do. I'm going to try to copy this over here. So I made a little rectangle that matched it. Okay. Okay, and I'm going to do 57 times 15. Remember that first number always goes on the bottom. Okay, and that's how we're going to do it. So, if you remember, this second number goes on top. 57 is going to go down here, so I'm going to do 57. Okay, 57. All right, so let's get started on this. Let's see how this works. So I'm going to multiply these 2 numbers by up here. So I'm going to multiply 7 times 15 first. Okay, and then I'm going to multiply 50 times 15 second. And that might look like a lot. It looks pretty intimidating over here, but over here, check it out. I'm going to use a different color pen to kind of walk you through this one, okay? So let's do that. First, do you remember which number we always start with? Yeah, the bottom number in the ones place. So I'm going to say 7 times 5. 7 times 5, if you know your math facts, that's 35, right? So I'm going to put down my 5 and carry a 3. Okay, that's what I'm going to do with that. With me so far. Remember, we're just doing 7 times 15. So 7 times 5 is 35. Put down a 5, carry the 3. 7 times 1 is 7 plus 3. That's right, it's 10. So I just put a 10 in. So my answer there is 105. So 7 times 15 is 105. Let's write that in there so you can see that. Great. Now I'm moving on to my tens place. Over here, this 5 is really a 50. So in order to do that, I need to say, all right, I'm in my tens place, so I need to remember somebody. Who is that somebody? Oh, that's right. It's Bob. Let's put him down before I begin. Good. Put that 0 in. Great. Now I can just multiply these numbers just as they were ones. What's 5 times 5? Right, I start here, go this way. 5 times 5 is 25. So I put down the 5, and I need to carry the 2. So I'm going to get rid of this guy. I'm going to make sure I cross him off and just put a 2 next to him. Okay, because I already used that 3. That's where this can get confusing, I suppose. So then I say 5 times 1 is 5, plus 2 is 7. I get 750. So 50 times 15 equals 750. Now let's add them up. 5 plus 0 is 5. 0 plus 5 is 5. 1 plus 7 is 8. And there's my answer, 855. Okay? That's pretty cool, right? What do you think? All right, I hope it's going okay for you. Okay? So, let's see what this has to offer down here. All right, cool. So now we're getting rid of the area model. If you want to still draw it because it helps you out, that's fine. But we're going to stick with doing this, all right? Okay, so solve the following using 2 partial products. And this is the way we've always done it. Well, all the teachers in the school have. Visualize the area model to help you. So visualize, just picture it in your head. Okay? All right. So here we go. I've got 46 times 25. I'm learning here that I start with the base number and I work out. So 46 times 25. All right, good. So now my base number here, I'm going to do, it would be the side number over here, right? So I would do 6 times 25 and then 40 times 25. So that's the first thing I'm going to do. This would be 6 times 25. So I'm going to write that here. 6 times 25, okay? My second multiplication is going to be 40 times 25, okay? Because that 4 is in the tens place. All right, well, let's get started here. I'm going to change colors, okay? So 6. So I'm just going to treat this like a regular 2-digit by 1-digit multiplication. 6 times 5 is 30. Put down my 0, carry the 3. Great. 6 times 2 is 12, plus 3, that's 15. Great. So I can see here that 6 times 25 is 150. And I know that. I know how to count by 25s. They're quarters. 25, 50, 75, 100, 125, 150. That makes sense to me. Now 40 times 25, now that's a lot. So let's see what we got to do here. So do 40 times 25. Now if you remember, I already did this 6. So this 6 is done. I don't have to use them again. I'm going to work on 40 times 25. So when I move over to the tens place, who do I need to remember? Just shout it out when you know. Just say it. That's right. I need to bring down Patrick. Or whatever name he came up with is Bob. We'll say Patrick for St. Patrick's Day for today. So I need to bring down that guy. That's a 0. Got to hold that place because it's a 10. Now, once I brought that 0 down, I can treat these all like 1s. What is 4 times 5? That's 20. Put down the 0. Carry the 2. Oh, there's already a 3 there. Oh, I already used that 3, so I'm just going to get rid of them and just write my 2 there. Good. And then 4 times 2 is 8, plus 2 is 10. Wow, it's a nice even 1,000. Who would have thought, huh? That's weird. Okay, so now I'm going to add these guys up. 0 plus 0 is 0. 5 plus 0 is 5. 1 plus 0 is 1. 1 plus nothing is 1. 1,150. Bam. Done. Cool, right? All right, let's try this guy out. Now remember, anytime, if you're getting the hang of it and you want to just go ahead, go ahead. But remember to stop and check in though, okay? Once you get confused, it's time to stop and rethink. All right, teachers, you can interject or show your way at any point. All right, here we go. So I have 62 times 18. I always work from that bottom up. All right, I'm starting to get good at remembering that, okay? So let's do that. So 2 times 8, that's 16, right? So I'm going to put down my 6, carry the 1. 2 times 1 is 2, plus 1 is 3, right? So what did I do just here? I just did 2 times 18. 2 times 18 is 36, isn't it? Yeah. Okay. Now I'll move on to my tens place. When I move over to my tens place, this is going to be 60 times 18. Now when I move to my tens place, I need to remember somebody. Who is that somebody? Shout it out when you know it. That's right. It's Bill. I'm going to keep changing the name on everybody, okay? Patrick, Bill, Bob. I'm going to put down that 0 there to hold that place, okay? Name them whatever you feel like that you can remember. Don't forget about Bob, right? Now I can just treat all these numbers as if they were 1s. 6 times 8 is 48. Put down the 8, I carry the 4. I'm just going to turn that 1 into a 4. Isn't that cool? Don't have to cross them out, it's going to change it. Then I say 6 times 1 is 6, plus 4 is 10. And there's that, it's 1,080. I add it up. 6 plus 0 is 6. 3 plus 8 is 11. Carry the 1. 1 plus nothing is 1. 1 plus nothing is 1. 1,116. Good. We're getting there, kids. Doing a good job. Now, check this out. It just took everything away down here. So these last two, standard algorithm. See how we transitioned Okay, we talked about that transition in our I can statement. We transitioned from this to this, okay, to this, to this. Now, we're here. Standard, regular old algorithm. Cool. Okay, so here we go. Here's step one. Now we start here in my ones place in the bottom. This is 46 times 39. So I'm going to say 6 times 9, right? If you know your multiplication facts, it's going to be really, really a dream for you. 6 times 9 is 54. So 54. So I have to put my 4 down here because that's in the ones place and I carry the 5. I'm going to have to cross that guy out after I use him. Then I come back to this guy again and he needs to be multiplied by that 3. 6 times 3 is 18 plus 5 is 23. Good. So I use that guy. He's done. Right? Now move over to my tens place. Right? Here's my tens place. Don't forget about your guy down here. Whatever you named him. I'm going to put that 0 in to hold the place because it's a 40. Once I put that guy in, now I can treat them like they're ones. 4 times 9 is 36. Put down the 6. Carry the 3. 4 times 3 is 12. Plus 3 is 15. Add it up. 4 plus 0 is 4. 3 plus 6 is 9. 2 plus 5 is 7. 1 plus nothing is 1. 1,794. Nice. And the last one, okay? I'm going to use green in my last one in honor of St. Patrick's Day today, okay? So here we go. Remember, I start with the base number, 23 times 78. I'm going to start with this ones place right here, okay? So 3 times 8 is 24. Put down the 4, carry the 2. Now come back to my 3. I must multiply him by this number as well. 3 times 7 is 21, plus 2, 23. Huh, same number. Now I move over to my tens place. But before I begin any multiplication, I'm going to cross this guy out too. I must put in my number. I must hold the place. So once I put the 0 in, whatever you name them, that's good. Now I can treat the rest of these like ones. 2 times 8 is 16. Down the 6, carry the 1. 2 times 7 is 14. Plus 1 is 15. Good. So I end up with 234 plus 1,560. 4 plus 0 is 4. 3 plus 6 is 9. 2 plus 5 is 7. 1 plus nothing is 1. And there it is. All set. Okay, so now, I know in my class, we're probably going to get out the whiteboard and do some work on this, do some practice, okay? We'll go through a little bit with that with my class here. With your class teachers, if you have time, I fully suggest, writing some numbers on the boards, come up with them, and have the kids work through them on the whiteboards or some scrap paper, all right? You can get a lot out of this, all right? All right, kids, nice job today. Great transition. I feel like you're starting to get it. I knew you were yesterday, so couldn't be more proud of you. The teachers are proud of you as well. All right, keep grinding. We'll see you tomorrow.